Hi, in this video we're looking at integrating by parts. This is the final section of the integration topic, and you'll no doubt be pleased to know. Unfortunately, it's also possibly one of the harder ones that you're going to have to work with. Right, so from work we've done earlier, you will know that the product rule looks something like this. The derivative of the product uv over dx is going to be, oops, I need a pen, is going to be u times dv dx plus v times du dx. Now, I'm going to take the integral of both sides. So in other words, I'm going to, whoopsie, what's happened there? There we go, back to normal size. I'm going to say the integral of the derivative of uv dx, the integral of that, is going to equal the integral of u dv dx plus the integral of v du dx. So I've done the same thing to both sides. Now, if I go and take the integral of a derivative of a function, it's like taking the square of a square root, or squaring a square root, or taking the square root of a square. I'm going to go back to the original thing that I started out with. So in other words, I'm going to be left with here with uv is equal to the integral of u dv dx plus the integral of v du dx. And if I go and rearrange that, bring this last element over to the other side, I'm going to end up with this statement here: the integral of u dv dx is equal to uv minus the integral of v du dx. And what we have now is the integral of two things. One thing that is a function by itself, the other that is the derivative of some function. And this is what we refer to as the integrating by parts. And there is the formal equation of it. And a key thing to notice here, you need to determine what are going to be the elements that you're going to assign to u and which element is going to be assigned to dv dx. And to help you with that process, you just need to remember these two things. Du dx, this part over here, that needs to be something that's easy to differentiate. And if you can differentiate it down just to a constant number, like 1 or 2 or something like that, it is really good, because then all you have to worry about integrating this side is simply the function v. The other thing that you need to be able to pick up on is that dv dx, this part over here, must be something that's easy to integrate. So we'll work through a couple of examples on this. No, we don't need that. And we'll see how this goes. So here's our first example, the integral of x times e to the 3x dx. And I need to decide which element is going to be u and which element is going to be v, or dv dx. So to start out with, I'm going to say let u equal x. My reason for saying that is that it is then very easy to do this differential, du dx, because du dx is simply going to be 1. So in other words, I'm making this part over here u. In other words, this part here must be dv dx. So dv dx is equal to e to the 3x. and I want to go back to find out what, I want to go back and find out what v is. So in other words, I need to integrate both sides, and I'll be able to get here that v is equal to the integral of e to the 3x dx. In other words, it's going to be 1/3 e to the 3x. So now that I've identified what v is, I've identified what du dx is, I can now go and plug into the formula, this formula up over here, in order to be able to integrate this function. So this expression here can be written this way: u times v, so it's going to be u, which we said was x, times by v, which was this thing over here, 1/3 e to the 3x. And then from that, we're going to take the integral of 1/3 e to the 3x, and we'll multiply that by du dx. Du dx we've got over here, so that's simply going to be 1 dx. And if we tidy this up now, we're going to get 1/3 x e to the 3x minus the integral of e to the 3x is 1/3 e to the 3x, so I'm going to end up with 1/9 e to the 3x plus c. And so there I now have the integral of that rather complicated looking initial function, x e to the 3x. Obviously I could go and tidy this up a little bit more. I could take out, I could take out a 9th e to the 3x. If I did that, then I'd be left with 3e to, no, just 3e, not 3e, 3x minus 1 plus c. Either of those forms would have been perfectly fine. Let's move on to another example. So here we've got the integral of x cos x dx. Again, we need to determine which elements are going to be u, which elements are going to be dv dx. Let you have a little think about that. Well, remember, I want to make the derivative of u as easy as possible. And there's nothing easier than deriving x. It's because I know that du dx is simply going to be 1. So in other words, dv dx has to be cos x. The question you then have to ask yourself is, what did I derive to get cos x? And in other words, that's going to tell me that v is going to equal sine x, because the derivative of sine is cos. So now that we've got those features sorted, we can now go back to our integration. There's going to be uv, so u is x, v is sine x, minus the integral of sine x, and then du dx, which once again is 1 dx. First term, I'm not going to deal with anything at this stage, just going to leave it like that. And now I need to look at the integral of sine x. The integral of sine x is going to be minus cos x. And so my final answer is going to be x sine x plus cos x plus c. And there we have the integral of that function. This can go further. We can look at definite integrals involving products. And now we need to look at, so we now need to look at this one. Now in the past I've always gone and made x the value of u. However, this time I can't go and do that, because if I go and make dv dx equal to ln x, I'm going to have to integrate that, and we don't have a formula for the integral of ln x. So I can derive ln x, but I can't integrate it. So I'm going to start off and I'm going to say u is equal to ln x. So in other words, dv dx is equal to x. Well, if u is equal to ln x, then du dx is going to be 1 over x. The derivative of ln is 1 over x. And here the value of v must be x squared over 2. If I go and integrate that. So now I've got my two parts, or my 4 elements rather, and now I need to go and complete the integration. So it's u, which is ln x, times v, which is x squared over 2, minus the integral of x squared over 2, times by du dx, and du dx we've seen is 1 over x dx. So what have we got? We've got a half x squared ln x, and this x squared over 2 multiplied by 1 over x, that's going to simplify down to x. So I'm looking at minus a half the integral of x dx. So I'm going to have a half x squared ln x minus a half, the integral of x is going to be x squared over 2. So it's going to be another half x squared plus c. So in other words, I can take out of here a quarter, not ln x, a quarter x squared, and I'm going to be left with ln x, 2 ln x minus 1 plus c. And I've gone and forgotten that, in fact, we're not dealing with an indefinite integral, we're dealing with a definite integral. So I don't need to do this line over here. I've got this line here, and I'm going to be working this out between 2 and 8. So what are we going to have here? We're going to have a half 8 squared times by the ln of 8 minus a quarter of 8 squared. That's the first part. And from that I'm going to take away a half 2 squared ln 2 minus a quarter 2 squared. Let's make a little bit more space there for myself. So I'm going to have 64 ln 8 over 2 minus 64 over 4. And then I'm going to have minus 4 ln 2 over 2 minus 4 over 4. And when we crunch all of those together, we're going to get 94 ln 2 minus 15. And there's my final answer. Last element before we go, and that is how we're going to deal with this integral over here. Now I told you just now, I said we don't have a way of being able to integrate the ln of x. Well, we can actually by integrating by parts, but it's a bit tricky. And what we need to do is we need to think of this thing over here, this integral, as being the integral of 1 times by ln x dx. If we do that, then we have our two elements that we can work with when we're working with differentiating by parts. So once again, I'm going to say u is going to equal ln x. So du dx is going to be 1 over x. And dv dx is going to equal 1. So in other words, v is going to equal x. That means I can launch straight into my integral and say this is going to be u, which is ln x, times by v, which is x, minus the integral of v, which is x, times by derivative of, or du dx, which is going to be 1 over x dx. So I'm going to have x ln x minus the integral of 1 dx. In other words, I will have x ln x minus x plus c, and so I could say this is going to be x ln x minus 1 plus c. And so I can get the integral of ln x, but it's a bit tricky. We get it through using the integration by parts. Right, enough from me. You now need to go and practice this. Goodbye.